Okay, we are starting Unit 1, Exponential and Logarithmic Functions Review. So one of the first things we have to remember is the comparison between exponentials and our log functions. So our exponential functions start as y equals a times b to the x, or we also see it as y equals b to the x. Where would the a have gone? Is a still there? A is hiding. Who can hide? It's a 1. So a is a 1. So if you don't see an a value in front of the b value, it is a 1. So they tell us a couple things about it. So the first thing is the a is our y-intercept. So if they don't show us an a, we know automatically it's going to cross through positive 1. That's our y-intercept. The next one, it says, we can also change the y to fx. So sometimes they do this to us. They say function of x equals a times b to the x. So sometimes they will change the y value and make it become f of x. All they're doing is this is another way of writing the y. Okay, so you have to recognize it's another way of writing y. And what they'll often do is they're going to show you the range. And they'll do the range like this. Okay, so we're going to do the common features for these. Now the b value, we've identified what the a value does. The b value, what's his job? Who remembers that? Anybody? It tells us up or down. So it tells us increase or decrease. And it tells us according to whether it's a fraction or decimal. Okay? I'll move that up in a minute here. Okay, so we're going to take a look at what our graphs look like and we're going to compare them. So an increasing graph and a decreasing graph. So a couple things about our graphs. We only use quadrants 2 and 1. So exponentials only use quadrants 2 and 1. So we could have an increasing function, this is an increase, or a decreasing function. This is a decrease. Okay, so increasing functions and decreasing functions. And again, they will always touch the y-axis, always, always. But the one they never touch is the horizontal asymptote, and that's the x-axis. So they're never going to touch x. They come real close to it, but they never touch it. So there's no x-intercepts ever. Okay? So that's the horizontal asymptote. Now, when we take a look at these, sometimes they're going to show us equations where they're going to adapt to what A and B do. So for example, this one might say, multiple choice, what is A and B doing? So I might have a couple choices here that might say A is greater than 0, B is greater than 0, or sorry, greater than 1. They could have A is greater than 0 and B is between 1 and 0. They could have A is less than 0, B is greater than 1, and D, A is less than 0, B is between 0 and 1. So that's how they could write it. Now, we need to understand what all those symbols mean. Whenever something is written like this, that means in between, okay? Hang on here. The symbols will always point to the left, and that just means in between. The B is in between those two numbers. Now, the A value, that's talking about the y-intercept. The B value is telling us whether it's going up or down. Now, here, the B value, if it's greater than 1, going up. Between 0 and 1, this guy's going down. Greater than 1, up. Between 0 and 1, down. So right now we know up, down, up, down. Now we look at our A values. So these guys say A has to be a positive intercept. A has to be a positive intercept. Here it's saying your y-intercept, negative intercept, negative intercept. That's what it's saying about the y's. Now, could we have an example where they say, hey, adjust what you know, and what would it look like if that happened? Okay, which one of those would match this situation? So there are situations that you're going to have to adapt what you know. So, let's match it up to begin with. Both of them on the right, on the top here, both of them are above 0, which means both of them have positive y-intercepts. So, the one here is an increase. He has a positive y-intercept, so he is going to be matching this guy. Okay, so this guy matches A. Okay, he's going up, and his y-intercept is positive. Which one is going to match the decrease on the right? Which one's going to match the decrease on the right? Pardon? D. A is less than 0 and B is going down. What kind of y-intercept do we have? Do you still have a positive one or a negative one? We've got a negative one or a positive y-intercept. Okay, how do I know that? Because 0 is right here. The y positives are up here. So that means he's got a positive y-intercept and he's going down. So B is going to match this guy. That guy matches there. Now, if we have to adjust something, how could I tell if this graph is going to match anything? Well, what I would do is I'd literally put numbers in for A and B and I would try and match them. So, letter C. I would take letter C and I would go, okay, well, if A is less than 0, I'm going to make my A number B maybe a negative 2. Then B is greater than 1, so it's got to be a positive number. So, or sorry, greater than 1, so let's just say, I don't know, maybe 3 to the x. So if I put that in my calculator, we want to see what we're going to get. So let's open our calculators. We're going to actually graph that to see. Whoa. So, here's my calculator. I am going to go to my y equals, and I'm now going to stick in bracket -2, bracket, another bracket, 3, bracket, exponent, x. Your exponent is always x for exponentials. Now, I'm going to graph, and we're going to see where it ended up. Oh, it's down there, and it's going the other way. So, it would match a situation. See that again? Okay. He's doing this. Okay. So, that situation, I stuck in a negative x-intercept and a positive going up. Okay? I shouldn't say positive going up because the b's are positive anyway. But it's going up. So, what did it actually do? It took what was going up and it did a reflection. So, it basically took the A graph and did a reflection. And when it did a reflection on the x-axis, this became a negative intercept, and then it started flowing down to the right. So that's what happened there. So C is going to match that graph. So process of elimination, what do you think the other one matches? D, good. So let's try D. So a negative y-intercept, and then we need to take a fraction or decimal to go down. Okay, I'll answer a question in just a moment. We're going to do this last graph. So negative y-intercept, and now I'm going to make this guy a fraction or decimal. So I'm going to go insert, I'm going to go 0.3. Okay, so 0.3 bracket, exponent x. Okay, I could go 0.5, anything between 0 and 1. Okay, and now I'm going to actually hit the graph button. Now we see it does what this is. Okay, so it basically did a reflection of this graph that's going down. Okay, it did a reflection. So that's how you would navigate when they show you all kinds of variables like this. Don't let it scare you. Put numbers in for those. Okay, and then literally take a look visually on the graph and see which ones match. Okay, so you could see questions like this, guaranteed pretty much. I've seen them almost on every diploma, where they're going to adapt what you know. Okay. All right. Oh, let's see here. Let's go into. Sorry, yep.
How come next to C you have written that it's going up, but it's actually going down?
Right. So B always tells us this part here is going up. But this being negative means it's going to be a reflection of the up, meaning it's going to go down then and be in quadrants 3 and 4. So these two right here are reflections. Okay? So initially they'll go up and down, but when they reflect, the up-downness switches. Okay? That's all it is. It's because of the negative y-intercepts. That's what's going on. Okay? All right, good question. Next, let's take a look at how a log would look then. So those are characteristics of exponential graphs. Okay? Now, a logarithmic graph, we take a look at log functions. So we'll just call this B, log functions. So again, log functions could look like y equals a log base b of x. Okay, they could look like that. Or it could look like function of x equals log base a of b. They could do something like that. Okay? Actually, we'll put an x there. Okay, so that's basically how they're going to look. Now, whenever we deal with a log, the number in front attached to the log is going to tell us whether it's increasing or decreasing. And that's if the base number is a whole number, okay, or greater than 1. So, this is an important if. The base is greater than 1, then the number in front attached to the word log tells increase simply if it's a positive number, or decrease if it's a negative number. Okay? So that's, I'm going to show you an example of that. So up or down is decided if the base number is greater than 1, it's decided by the number attached in front of the word log. That's what decides up or down, if the base is greater than 1. Okay? And not a fraction. And we'll do an example of this. I'll give you a moment to write that down. Okay, so here's a couple examples. So example 1. F of x equals 5 log base 2 of x. So, without even putting this into the calculator, I'm going to look at two numbers. I'm going to look at the number in front, and I'm going to look at the base number. And I'm going to look at the base number if it's greater than 1. Then I'm going to look at the number in front attached to log. And if it's positive, it's going to go up. If it's negative, it's going to go down. So, this one is positive, so I know that this is an increasing function. Okay. So, we're going to take a look and see exactly where we put this. We're going to go into our calculators, and we're actually going to graph it. So grab your handy-dandy calculator. And we're going to turn it on, go to y equals, clear it out. Now we're going to put in 5 log. Okay, hang on. I don't have log base on my calculator, so we have to remember how to put them in. So, if you don't have log base in your calculator, you're going to have to put it in like this. It's going to be 5 times, open brackets, log opens its own brackets, x, close the brackets, divide by, and then you're going to go log of the other base number, 2, make sure you close this bracket and this bracket. So you're going to open a bracket here, and then you're going to double close here. But you've got to remember to close this one too. So if you've got log base in your calculator, you're laughing. You type it in exactly the way you see it.
You go math and then you press page.
Yeah. Yep, if you've got the log base. But if I hit math and I go scroll down or scroll up, I don't have log base in here. Okay, some people do, I don't. Okay, so in my y equals, I'm going in, I'm going to go 5 times, open my brackets, log x, close my bracket, divided by log 2, double close. Okay? Make sure you've got it in there correctly. And now we hit graph. So what kind of function do we have? Increasing function. Good, good, good. So we're proving we've got an increasing function. Now this is called the change of base, how you have to put it in the calculator. That's called change of base. So whenever you don't have, if you don't have the log base in your calculator and you need to solve something, you do it by change of base. So if I had another example here, if I've got log base 3 of 5, and I needed to evaluate that, in my calculator, I'm going to type in log, it opens a bracket, I put in my 5, I close the bracket. Then I would divide by log, open a bracket, 3, close a bracket, enter. You don't have to double close on this one. Okay, so that's how you would type it in. Okay, so let's just take a look. We're going to type that in just in our normal regular screen. So log 5 brackets divided by log 3, close bracket, enter. And again, you get a decimal. So we're going to go to 2 decimal places, 1.46. So evaluated, this is going to give us 1.46. So again, that's if you don't have the change, or if you don't have log base in your calculator, you need to do change of base. Okay? All right, now let's take a look at what the graphs look like. We obviously looked at a few of them. I'm going to show you what the other ones look like. Okay, I'll give you a minute to finish writing that down. Okay, so here's the graphs. So we're going to talk about log graphs for a moment. As we just noticed in the previous example, our log graphs are only using quadrants 1 and 4. So 1 and 4 we're using only. And the last one we just did was an increase. Okay? And it had an x-intercept. Does anybody remember what the x-intercept is? It's 1, and it'll never change. In dash 2, we only have an x-intercept of positive 1. So 1, 0. So that means even if you have a decreasing function, no choice, it's going to go through positive 1. So if I've got, like I said here, this is a decrease. It's going from 1 to 4. Increases will go 4 to 1. Okay? That's the difference of those graphs. Now let's talk about what if we change the base number to a fraction. So we saw the base number if it was a number greater than 1, but what if the base is a fraction? Base is a fraction. What does that tell us? So if I have a base as a fraction, what does that tell us? So we're going to take a look specifically at an example. So we're going to get our calculators out again. And you're going to go back to your y equals. You're going to clear what's out in there. We're going to write 2 different equations in there. So the first equation that we're going to graph, just move that up for you. Okay, so we've got our calculators out. We're going to put a couple examples in. So the first example we're going to put in is y equals log base 5 of x. And the second one we're going to put in is y equals log base 2 over 5 of x. So those are the two we're going to input into y equals. So whenever we're putting two equations in that we want to see both of them, if you've got a color calculator, wonderful, there'll be different colors. I don't have one of those, so I'm going to go back to my left of my y equals, and that's where you're going to see that little dotted line switching. I'm going to hit enter once. That's just going to make it a thicker line. So my first equation will be a thick line, my second equation will not be. So the first equation I'm going to put in, log base 5 of x. So I need to remember that I have to use change of base. So the way I'm going to type it in my calculator is log x divided by log 5. Same thing over here. I'm going to write log x over log 2 over 5. Okay? Don't forget you need brackets because log will automatically open brackets. Okay? Okay. So log x, close brackets, divided by log 5. Okay, now I'm going to go to the next one. Log x divided by log 2 divided by 5. Log 2/5. Okay? So now we're going to hit the graph button. Okay, now we don't need to see the left-hand side of our graph, so we're just going to actually adjust our window. So we're going to take our x minimum, we're going to just go to -2. We don't need to see that. Okay? We don't need to see all the far away left. We'll just take our negative x and our window to -2. All right, graph. Ooh, what are you noticing? So, which one is increasing? The top one's increasing. Who can tell me why the top one's increasing? They both have a +1, because remember the number out front of log, it's the guy that tells us up or down, isn't it?
The base is greater than 1.
Not always. That's only if the base is greater than 1. Exactly. Our base isn't greater than 1. So that means if our base is less than 1, like at the bottom here, 2 over 5, you're noticing that one's going down. Okay? So the part that told us that it's going down is this. This guy's going down. Okay? And up here, this guy was going up because of the 5. He's greater than 1. Okay? Alright, so that's the differentiating piece between the logs. Okay, so you always have to look at the base number and the number in front attached. Now what if we change the numbers in front of log, one to positive and one to negative? How's that going to change things? Let's take a look. So we're going to go back to our y equals. And I'm going to go down one more to y3. And in y3, I'm going to make the first one, way up top here, I'm going to make him a -1. So I'm going to type in negative log x, close the bracket, divided by log 5. Let's see what that negative sign does. What should it do? If the guy right here is positive, or sorry, greater than 1, what should a -1 out front do? Make it go down. That's what it should do. Let's see what the third graph does. Let's watch the third graph. Okay, ooh, where'd he go? He went right in between these because he's a complete reflection. Okay, so he went right in between these. He's not going up, he's going down because we put a negative sign here in front of this one. Okay, that's what's the difference. All right, what do you think would happen if I put a negative sign in front of this guy? What happens if you put two negatives together? They make a positive, so let's check and see if that's going to work. I'm going to clear that guy out, and that's the one I want in there, and I'm going to clear this guy. Nope, I'm just going to go to the next part of him. Okay, I need to put 2 divided by 5 there. 2 divided by 5. So I want to see the original 2 divided by 5. Now I want to see the 2 divided by 5 with a negative log in front.
So, go back to talking about the base, whether it's a negative base or a fractional base. Same.
Your base will never be a negative. Whether the base is a fraction or base is greater than 1. Okay, that's what we're differentiating between. Okay? So now if I look on this one, we're going to take a look and see what happens. So I put a negative sign. Look what I did. I put a negative sign on the thick one. I put a negative and it's got the fraction. So the negative should tell it to go down and the fraction should tell it to go down. But two negatives are going to make a positive. So it's going to go up. So watch this shaded dark one. The shaded dark one should now be going up. Okay, so you see how that works, everybody? Okay. Just making sure. And again, like I said, if they just give you variables, put digits there. They literally put digits. So they could give you a question like this and say, which graph matches it? And they could give you a question that looks like this. Okay? They could show you this. And then you're going to see a negative sign out front and a fraction base. So basically the two negatives cancel each other out, and this one is going to increase for a function. Okay? That's what's going on with that one. Okay? All right. Let's move on to the next section. So I'm just putting increase beside it, because the two negatives will make it go to an increase. All right, so now we know the difference between all of them. The first thing we got to remember is if-then statements. So what if we have an if-then statement? Okay, so if-then statements. Okay, so here's my example. If log base 4 of x equals 5, then log base 4 of 3/4 x is what? So this is again an if-then statement, okay? So the first one, we have to first of all decide who x is. We have to solve for x. Are we able to solve for x on the left-hand side? Well, we can if we use our log laws. So we have to remember our log laws. So if I have something, how can I switch a log into an exponential equation and back and forth? Do you remember how to do that? Yeah, it's the 7 rule. Do you remember the 7 rule? Okay, so I'm just going to draw the 7 up here. So here's our 7 rule, there and there. So that means that 4 exponent 5 is going to equal x. That's the 7 rule. So the base stays the base, the answer becomes the exponent, and the x is called the argument. It now becomes the answer. Okay? So these two things, the x and the 5, switch places basically when you get rid of the word log. That's all that happens. So the word log disappears and the x and 5 trade places. Okay? So now we're going to solve 4 exponent 5. So how big is 4 exponent 5? 1024, correct? So, let's just move this up a little bit. So now we've solved that 4 exponent 5 is equal to 1024. So now we're going to put that in where this x is to solve for it. We're substituting in the next question. So I write my question, log base 4 of 3/4 times x. Well, x I need to write as a fraction because my 3/4 is a fraction. So any number can be put into a fraction by putting over 1. So I'm going to put my 1024 here and close my bracket. And that's all now going to equal my answer x. So our next step, we multiply tops, we multiply bottoms, and then we're going to take the answer at the top and divide by 4. So this is going to become log base 4 of 768. Did everybody get 768? Okay, so you take 1024 times it by 3, then divide by 4. Now, if we want to solve this, and if you don't have log base in your calculator, you're now going to solve it by going log 768 divide by log 4. So log 768 divided by log 4. And we're always going to go to 2 decimal places unless we're asked otherwise. We punch that in. It's going to give us 4.79. Okay, so we've got our if-then statements. So I'm going to give you guys one try. Here's a practice if-then statement for you guys to try. So if log base 3 of x is 7, then log base 3 of 1/3 x is how big? Okay, I'll give you a couple minutes to try that one. Okay, let's take a look here. First thing we're going to do is we are going to convert to exponential. So we have 3 exponent 7 equals x, which is equal to 2187. Then we substitute that in for x. So I'm just going to do the fraction. I'm going to solve the fraction first to get it to one number. So I'm going to have 1/3 times 2187 over 1. You're going to multiply tops, multiply bottoms. You're going to get 2187 divided by 3, which is 729. Okay? That's the number that's going to sit in the brackets. So now, our equation looks like this. Log base 3 of 729 is something. So now in our calculator, we're going to go log 729. Close my bracket, divided by log 3. Close my bracket. We're going to get 6. So, now, if we just put this and say is equal to x, if I wrote it this way, log 3 of 729 is x, we are changing it, and that's basically saying, let's put this over here, this basically says if I wanted the 7 rule, that 3 exponent x equals 729. So basically what we found is the exponent of 3 that equals 729. So now to check our work, we can say, okay, 3 to the 6th, is it equal to 729? Yup, we did it right. Okay, so that's how we know we can check our work. Okay? Okay, so we got to talk about log laws. What number are we at? Anybody know? D? Okay. Log laws. So this is saying that when you add 2 logs, the first one, you add 2 logs, it means you multiply their arguments. Log base 3 of 4 plus log base 3 of 9. That's going to give us, we change the plus sign to a multiply sign to combine them. And what we actually do is we take the 4 and the 9 and we multiply them. So we're going to get log base 3 of 36. And then we would solve it if we can. So we would type in log 36 divided by log 3, and we would get our answer. Okay? I'll let you guys solve that one. There's also going to be situations where we can use our log law where we cancel our base. When the base and the argument are powers of each other, we can cancel. So we're going to do situations like that in a moment. So what about if they're separated with subtract sign? We're going to do the exact opposite. So log base 2 of 16 minus log base 2 of 8. The minus sign in the middle, we're going to change to a divide sign. We're going to divide the arguments. So that's going to look like log base 2 of 16 over 8, which is log base 2 of 2, exponent 1. Now this is that situation I was telling you. If your log base is the same as the argument, you are able to answer it and solve it as the exponent. So when my log base and my argument are the same, these two numbers, I cancel them, including the word log. My answer is the exponent left over. So the answer to that guy is 1. Okay, it's an exact digit. The first one, log 36, divided by log 3, what do we get? 3.26. Thank you very much. All right, let's take a look at our third law. The third law, we're going to put some brackets in there. Or, sorry, some powers in there. So, number 3, I've got 2 log base 3 of 4. The 2 is going to come on and act as an exponent to the 4. So this is going to become log base 3 of 4 squared. And then you would solve like normal. Okay? So we end up with log base 3 of 16, which are not bases of one another, so you're going to have to solve that one separately. We should get 2.52. Okay, make sure you typed it in correctly. Okay. All right, so those are our basic log laws. Now we're going to take a look at canceling and reducing. So if I have log base 2 of 64. I have log base 2 of 64. Oh. First thing we're going to do, as we always do, is we check and see if 64 can be the answer of a 2 exponent something. So we basically guess and check 2 exponent what gives us 64. Now, we're going to find out 2 exponent 6 gives us 64. So we're going to have log base 2 of 2 exponent 6. And we're back to that same situation where we're able to cancel our logs and our answer is our exponent. So our answer for this case will be 6. We also have to take a look and see what happens. What if our argument number is a number 1? And this is one of our base rules as well. So, number 5, you have an argument of 1. Argument equals 1. Solution always equals 0. So, let's see how this works. So here's my example. Log base 3 of 1 is equal to x. So first thing we want to do is we want to convert it to exponential form. So we convert to exponential form. to solve for the x. The x will become the exponent. So, let's just make this guy a little smaller. Move that guy up. And we're going to do exactly that. So, that gives me 3 exponent x equals 1. The only time you're going to have an answer of 1 is if you have exponent 0. So if the x is a 0, you will always have an answer of 1. Anything exponent 0 gives you 1. So whenever your argument in a log is a 1, that's very unique, your answer will be 0. Okay, your answer will be 0. So we're going to go back to, we've just been doing some converting, but we're going to do back to converting exponentials and logs, just so we don't forget how to do that. We've been doing it, but let's actually do a little note on it. So, number 6, converting. Converting between forms. So, if I've got, we're going to go log to exponential, we use the 7 rule. Okay, use the 7 rule. Example, log base 4 of x equals 3. Okay, we're going to use our 7 rule. That creates a 7, which makes 4 exponent 3 equals x. So whenever you convert forms, the x, the argument, and the answer switch places, and the word log disappears. The base stays the base. That's super important. Whenever you convert back and forth, the base stays the base. Okay, so your base will always stay your base. Now we're going to go back and forth to the other way. We're going to go exponential to log. All right. Let's say we've got five to the 4th equals x. And I want to know how to change that. First step, you write the word log. Second step, you put the base number down by the G tail. Okay, it's got to go way down by the tail. Then you've got 2 spots left. Move it all together. Okay, so we have 2 spots left, and we have to know where they go. So the rule is, these 2 switch places, the 4 and the x. So on top of the 5 now, I'm going to have the x, and the 4 is going to go after the equal sign. Okay? And then your 7 rule will work to get you back to log, or to exponential. Okay? Write those down, check your work. Okay. The next one. Are we on letter E or F? Where are we at? E? Okay, so letter E is going to be expand. Expand using logs. Okay, here's our first example. Log base W of x squared y cubed over z. So we're going to find out how to separate all those. So we have to remember that if things have been put into a fraction, that means there must have been dividing. Dividing would turn into a subtraction. And if things are sitting side by side, it means multiply. And the multiply, we're going to turn it to a adding. So these 2 sitting side by side are multiplying. These guys are dividing. So we're going to write however many items are in my brackets here. I've got 3 different items, so I'm going to write the word log W 3 times. So here's my log W. Log base W. Log base W. Log base W. Okay, so we're separating with log, so what we're going to do is we're going to start with our first one on the left. So he always goes first, so we've got x exponent 2. Then we've got y cubed, we're going to put y cubed in. And then we've got z. So we put z at the end. Now we have to find out what signs we're going to put in between the words log. So, if they are connected by a multiply sign, what do we change it to? A plus sign. So we're going to change a plus sign between those two. Because the z is being divided, he's going to be joined by a subtract sign. Okay? And that's how we would separate those. Okay? Now there's one more thing we could do to these guys. What could we do to these guys? It would be one more thing.
If the exponents over to the coefficient.
Exactly. So these exponents could come down in front. That's one more simplification. Okay? So we need to also do solving same base equations and then solving non-same base. So we're going to discuss those next. Okay, so that's how you separate logs. The next one, letter F. Solving same base exponential equations. These are all our main outcomes. And I'm going to clone that page. There we go. So, solving same base exponential functions. So, when we solve same base, when bases are the same, we drop the base and just solve like a normal equation. Like a normal linear equation. EQN is equation. Okay, so we solve it like a normal equation. And we'll throw up an example when you're ready here. I'll give you a minute to write that down. Okay, here's our example. Let's have 2 exponent 4x plus 3 is equal to 4 exponent x minus 5. So the first thing we're going to notice, the bases are not the same. But we know that 4 will go to a base 2. So because of that, we change 4 to a base 2 right away. So we're going to write the rest of the equation. 2 to the 4x plus 3 equals, now I'm changing 4 to a base 2, 2 squared. Now this exponent he originally had must go in brackets. Now that our bases are the same, we're going to drop our bases, and we're just going to solve for x normally. Now because there are brackets, we've got to multiply that 2 into the brackets. So we're going to have 4x plus 3 equals 2x minus 10. And now we are going to move our x to the left and move the constant to the right. So we're going to minus 2x to both sides, and we're going to minus the 3 to both sides. And that's going to move them sides. So now the negative 2x, or the 2x disappears on the left, on the right, and the 3 disappears on the left. And we add like terms on both sides. That's going to give us 2x equals negative 13. We divide by our 2, of course, and x is going to be negative 6.5. Because it's an exact decimal, you can change it to decimal form. That's how we solve same base equations, okay? Because there was an x on both sides, this would be considered a standard of excellence, believe it or not. Because there is x on both sides, and you've got to multiply into a bracket here. So this would be considered an SE question, okay? Now, how do we adapt these questions and make them a little bit harder? Well, we change the bases, and we make the bases where you can't have them the same. So we have to learn how to solve non-same base equations, and there's 3 types. Okay, let's go to the next one, letter F, non-same base. Huh? Oh, it's G, sorry. Oh, and I cloned the page too. It is G. So we're on G, solving different base equations. So if they've got different base equations, the biggest thing we need to remember is you have to convert to logs. Convert to log form. Okay? So that's the biggest thing. Now, if x is on one side, you basically convert to log form and solve. If x is on both sides, you're going to log both sides. So like I said, there's 3 types of examples. Here's example 1. So, let's go with 2 exponent 5x equals 3 exponent x minus 2. Actually, we're going to make it x minus 4. Let's have all different digits. Hang on. Let's just do this. No x on the right. We got to do the basic equation first. Okay, so x only on one side. So it's our first type. So variable is only on one side. The other guy only has a hidden 1. Okay, the bases are different. So the first thing we do is convert to log form. So this is where we do this. The 7 rule. So, log base 2 of 3 is equal to 5x. Okay? So we get to our log form. So we convert to logs. Now we solve the left-hand side, and then we divide the 5 out. Or we can divide the 5 out like this. Divide the 5 out, divide the whole thing here by 5. So you would solve the complete left-hand side first, then hit enter, then divide by 5. Okay? So let's plug that in the calculator. So again, without log base, I have to type in log 3, close my bracket, divide by log 2, close my bracket, enter. There's my answer. Now I divide by 5. Divide by 5. Enter. So I get 0.32. So the answer to this guy, x equals 0.32. Okay? So that's the first type of solving exponential equations. Okay, the second type we're going to take a look at is going to be when we've got a variable on both sides and different bases, of course. So 2x plus 3 equals 3 exponent x. In this case, we cannot actually change it to log form because we have a variable on both sides. So in this case, we do what's called logging both sides. So we basically rewrite what we just wrote, 2 exponent x plus 3 equals 3 exponent x. And we write the word log in front of it. Log has a hidden base 10. If you want to write the 10 in so you remember it's there, you're more than welcome to. Now the rule is, if you've got a combined exponent, we put it in brackets and it goes and sits out in front of the word log. So we move our exponents down in front, and we're going to have x plus 3 log 2 equals x log 3. Now, on the left-hand side, because we have exponent in brackets, we need to split that. So we're going to split, meaning it's basically the distributive property. Log 2 multiplies in the bracket both of them. So we're going to get x log 2, and we're going to get plus 3 log 2. Oops. Log 2, not 3. Perfect. Equals x log 3. So we want x on the same side. So we're going to change this x right here. We're going to take it to the other side. Now, if we take it to the other side, we have to write it after what's sitting there. Because whatever originates there on the right-hand side has to sit closest to the equal sign. So now we've got 3 log 2 is equal to x log 3. To take over, we have a positive sign hidden in front of that. So we have to subtract x log 2 going over. So we're going to subtract x log 2. So that's what sits behind. We have negative or subtract x log 2. That's what we're connected by as a subtract sign. Now we're going to factor out x. So on the right hand side we've got 3 log 2. Sorry, on the left. We factor x out now. Log 3 minus log 2. And now we can divide that out to both sides to solve for x. I'm going to flip-flop everything both sides. So I like x on the left. So I'm just going to write it again and move things across. So I want this guy with the equal sign over there. So as long as I don't change anything, I didn't change anything, positive and negative signs stay the same. I just changed what side the equal sign are on. So now we're going to divide out what's sitting beside x. We're going to divide out log 3 to both sides. So log 3 minus log 2, and on the right-hand side, log 3 minus log 2. Now there's different variations. We would cancel the left-hand side out. We get x equals the expression we have on the right. Now, this is one possible answer. There's a couple different possible answers. How come? Because we can use our log laws. We could put that 3 on as an exponent. We can combine these by dividing them and writing log once. So I'm going to do exactly that. So on top, we're going to have log 2 cubed divided by log 3 divided by 2. Now 3 divided by 2 is 1.5 exactly, so you could use that. So then this would also become log 8 divided by log 1.5. So each of those are exact value answers because they have not been solved or rounded. Now if we want to solve our answer and round it, I'm going to put the numbers in the calculator. So we're going to have log 8, close my bracket, divided by log 1.5, close my bracket. And I'm going to get 5.13. So my answer for x in this case, x equals 5.13. Check the work, write your steps. Okay, there were 2 main types, not 3 main types of equations, pardon me. So we have covered our 2 main types. Now we're going to take a look at problem solving real quick. The 3 major types of problem solving we have are problem solving with logs. First one we have is finance. So they take our equation, y equals a times b to the x, and they change it to a equals p, 1 plus or minus I to the x. Okay? So, p is still, he's the a value, which means he is the y-intercept. This tells you up or down, just like the b, because this is the b value. So it's going to tell you up or down. If there's a minus, it'll be down. If it's a plus, it'll be up. You'll also be able to tell whether it's a number between 0 and 1. 0 and 1 is going to go down. And then if it's greater than 1, it's going to go up. So those are our finance questions. N is years, they will tell you that. So you have to remember that. We also have depreciation. For the depreciation question, you're going to get y equals a number, bracket, 0 point, a number, exponent, x. Now, this is not your depreciation rate. You're going to take 1 minus this number to get the depreciation rate. Okay? That's how you always find that. The second type we find is we find doubling or tripling. So doubling, tripling, or even half-life. So a doubling question could look like this. Y equals, maybe you've got 100 bacteria or 100% of bacteria, and it's doubling, and you want to know how fast it's doubling. Now the x can be an exponent that is a fraction actually, which would be t over p. The p on the bottom is the period you measure it over, or sorry, is the how often it doubles. So this is the doubling time. How often it happens, the doubling time, and then the top one is the time period you measure it. The time period it is measured over. It is measured. Okay. Okay, if we do a tripling would be very similar. If it's half-life, it would be similar, only so this could change. So the doubling, it could change to 3 is tripling. And again, if it's 1/2, it's half-life. Okay? And again, you're solving them either with logs, or you can put them into y1 and y2 in your calculator and graph it and see where they intersect. Okay? Then the last two types, well, the last three types we have for logs is we've got pH, we've got magnitude for our earthquakes, and we've got decibels for the hearing scale. Now, they're all going to be set up very similar. We're going to have y equals log x, and that's going to be for your pH. And the y actually is pH, and it's negative log x, pardon me. Let's rewrite that. So pH equals negative log x, and x is equal to the hydrogen ions concentration. Magnitude of earthquakes and decibels. Now decibels is a little bit different because magnitude and pH can also be changed to a base 10. Okay? Change to base 10. Where it's going to be the intensity is equal to 10 exponent magnitude 1 minus magnitude 2. So magnitude 1 minus magnitude 2, or it could be pH 1 minus pH 2. It depends on what you're talking about in the situation. Now, if it was decibels, the only thing that's different with decibels is this part. It is considered a fraction, so you'd have to put it in a bracket. Sorry, there's more than one item as your exponent. Now, if it's decibels, they're going to change that. They're going to say intensity equals 10 exponent, and the exponent is going to be divided by 10. So it's going to be decibel 1 minus decibel 2, and then all divided by 10. So again, we have to remember that your exponent, there's more than one item, you must put it in brackets. And those are our three main types of problem solving. We'll get into those with more depth with actual problem solving questions that we will practice. This is the end of basic review for logs and exponential functions.